Continuing with the Unit 5 review for Algebra 2, we're on number 12. Number 12 says the square root of negative 8. Now once we take the square root of a negative, but now we know we're dealing with I. So the first thing I'm going to do is take the I out. Okay. That was technically using the product rule, just to kind of remind ourselves what I just did there. I used the product rule, right? And the square root of negative 1 we express as I. Okay. Kind of coming back over here so I have some more room. So I got this right now. Then I can simplify that. So it's basically I times root 4 times root 2. And then we're looking at I times 2 times root 2. And it's customary, guys, remember to write this as 2I root 2. And those are all being multiplied right there. Those are all being multiplied. 13. You always have to deal with the i's first. Okay. So I'm going to do 13 and 14 kind of simultaneously because this is really tricky here. Okay. And this is really a question of order of operations. Now, this is how the questions are written. In question number 14, you can think of it like this. Okay? And remember, radicals fall under, when it comes to order of operation, they fall under the category of exponents. So over here, I'm going to deal with the I first. So I'm going to say basically I root 6 times I root 6. Okay. Over here, since I have the parentheses, this is really going to turn into 36. I really have a positive number under there, because a negative times a negative is a positive. So now over here, I times I is I squared. Root 6 times root 6 is just 6. Okay. And if we remember, I squared is negative 1. So this equals negative 6. Over here, the square root of 36 is just positive 6. Okay, so those questions are not exactly the same. 15. 3 root negative 25. Okay. So the first thing I'll go ahead and deal with is the I. Okay. Take out the negative. And then I'm looking at 3I times 5, because I know what the square root of 25 is. So the answer here is just going to be 15I. 16. 16 says square root of negative 18 times negative 12. So we got to deal with the i's first. So I'm basically looking at negative I all over 18 times, times I, not negative I, just I, times 12. Simplify this a bit so I can say this is the same as 9 times 2. This is the same as I times root 4 times root 3. So this, I'm going to put this 3 out front. So 3I root 2 times this 2I root 3. So now I'm going to multiply stuff. So 2 times 3 is 6. I times I is I squared, or negative 1. And root 2 times root 3 is root 6. So the answer is negative 6 root 6. 17 is 9 minus 6i minus 2 minus 4i. And this is simply combining like terms after we distribute the negative. And we're looking at 9 minus 6i minus 2 minus 4i, plus 4i. And so we're looking at 9 and 2, negative 2 is 7. Negative 4 and, negative 6 and positive 4 is negative 2i. And I want to write this in the complex form, right? In the a plus or minus bi, with the real part first and the imaginary part second. $18. Now 18 says negative 4 all over I. So this is simplified, it just needs to be rationalized. So I'm going to multiply this by I over I. Okay. And then this equals negative 4I all over I squared. Okay. And so that gives you negative 4I all over negative 1. The answer is positive 4I. 19 says 3I times 7 minus 2I. Okay. And so this is just distribution property. So this turns out to be 21I minus 6I squared. Okay. Now I can simplify this a bit. This is going to be 6, and then I squared is negative 1. So I'm going to write this in the complex form. This is going to be the real component, so it's going to be positive 6 plus 21I. Right? And I wrote that in the A plus BI form. 20 4 minus I times 5 plus I. And looking at this is a FOIL situation, right? So I'm going to go ahead and FOIL here. And I'm looking at 20 plus 4I minus 5I minus I squared. Okay. And this turns out to be 20 minus I. And remember, this is going to be minus negative 1. Okay, because you got to think of it like this. So you can see it's going to be a positive 1. So we're basically at 20 minus I plus 1. Combining like terms, I'm looking at 21 minus I. 21. 21 is 3 plus 2I squared, and what that really means is 3 plus 2I times 3 plus 2I. So I have to FOIL this. So first times first is 9 plus 6I plus 6I plus 4I squared. And so this gives me 9 plus 12I plus 4 times negative 1. So that's going to be a negative 4 right here. So that's going to be positive 5 plus 12I. 22 22 is 8 minus 7I all over 2I. I can't cross anything off because this is like a binomial up here. Okay, I got to take all of it out or none of it out. So here I'm just going to rationalize this thing by multiplying by I. I could multiply by 2I, that's just going to be more to reduce. Remember, all you have to do is multiply by the radicals in the bottom. Unless it's a binomial, then you have to use the conjugate. So this is going to equal, do the distribution property up top, 8I minus 7I squared all over 2 times I squared. Okay. And so this is going to equal 8I minus 7 times negative 1 all over 2 times negative 1. Okay. So this is going to, you can see this is going to turn into positive 7. Okay. So I'm going to put that out front because remember you want to have the imaginary part second. Over negative 2. Now this is not in the complex form because you can't have a single fraction. So I got to break this up to 7 over 2 negative, right? Minus 8I over 2. You can see that's going to reduce. So this is going to equal negative 7 over 2 minus 4I. 23 4 plus 3I all over 2 minus I. And here once again I have to rationalize it, so I'm going to multiply by the conjugate. Okay. And by doing this I got a FOIL up top. And I'm looking at 8 plus 4I plus 6I plus 3I squared. Down below I could use a shortcut, but I'm going to go ahead and FOIL it. So 4 minus 2I plus 2I minus I squared. And so what this turns out to be is 8 plus 10I plus 3 times negative 1 all over 4 minus negative 1, which you're going to see should be plus 1. And so we're looking at, this is going to be negative 3 right here. So positive 5 plus 10I all over 5. And then I got to put this into the complex form by dividing up the fractions. 5 over 5 plus 10I all over 5. And lastly, just reducing, I get 1 plus 2I. And let's look at number 24. This will be the last one for this video. So looking at 24, we're looking at 4 plus I all over 3 plus I plus 7 plus 2I all over 1 plus I. Well, I can't add these because they don't have common denominators. So I can find common denominators, or I can use the conjugate and clear it. I'm going to go with the conjugate first. There's advantages either way, I guess. But I'm going to go ahead and rationalize it first. Okay. So these are going to get multiplied by different things, as you can see, because they are different conjugates. So up top here, I'm going to go and use the shortcut now for the bottoms. This only works for I, it doesn't work for radicals. So we're looking at 12 plus 3I minus 4I minus I squared. And if I use the shortcut, it's this one squared plus that one squared. So 3 squared plus 1 squared plus over here, foiling on the top, 7 minus 7I plus 2I minus 2I squared. Down here we're looking at 1 squared plus 1 squared. So over here I'm going to realize this is a negative 1, so that's going to turn to positive 1. So let's see here. Minus 4I plus 1 all over 9, 10 plus 7 minus 5I plus 2, because that's a negative 1, all over 2. And then we're looking at 13 minus 4I all over 10 plus 9 minus 5I all over 2. Okay. Now I need to get common denominators over here, and I'm going to multiply that by 5 over 5. And this gives me 13 minus 4I all over 10 plus 45, because this is going to be distribution, minus 25I all over 10. Now this is addition, so now you just add the numerators. And so we're looking at positive 58 minus 29I, and I gotta divide both of these by 10. I need to have some equal signs in here. Okay, and this one here will simplify a bit. I can take a 2 out of those, so that's what, 25 plus 4. So 29 all over 5 minus 29I all over 10. That would be our final answer.